My name is Roman Samchuk, and I'm Engineering Project Manager at SDC Verifier. Today, I'm going to hold this webinar. It's all about optimizing your FEA workflows, integrated software solutions for standards-driven design, as you can see in that title topic. I'm going to start sharing the slides, and one more thing, telling you in advance. If you have any questions, we will have a Q&A session in the end. So basically, there we will discuss all of your questions you have during the meeting. But if you'd like to discuss something very specifically, and there is no problem to unmute yourself, interrupt me directly, and then we can discuss it during my presentation. So this is a very short agenda. I'll start from a short introduction. Then we'll talk about how can we optimize our FEA workflow with unified platform. We will talk about different ways to automate your code compliance. Also, if you have multiple standards compliance. Talk about your documentation, how you prepare it, how to better do that, optimize your structure, and maybe some practical suggestions to facilitate your process. So, couple of words as to who we are. Maybe not everyone is aware of that. We are the company who mainly does two things. It's been founded in 1998 as engineering consultancy services company, but then we've noticed that there are a lot of pain points in terms of our engineering solutions. So we started developing our software, and now we have over 30 people in the company, lots of finalized projects. And I see a message in a chat that you see a wrong screen. Is that true? Maybe let's do it another way around. I will simply share not a window, but all screen. Just a moment. That will be easier. Yeah. Oop. Like that. And like that. So, is it now better? Just to confirm it quickly, because that's important to see information in a way I want you to see it. Yeah. Okay, good. So now we grew to a pretty large company, and we keep growing in that direction, basically delivering the best software solutions to our clients as well as engineering consultancy services. But the main topic today is about how can we help you out with your specific solutions. So I would like to start from a general overview, saying that there are many different software solutions in the market. So whether it's FEA software or CAD software, you probably heard about all of them. And basically, I would say that regardless the software you use, there are typical and common pain points in the projects you went through or you have been walking through. So let's talk about briefly what are these main points. First of all, if you want to create to finalize a certain design, and whether it's a new design or existing design, you start with a simple CAD model or step file or drawings or whatever, picture, photo. Idea is that you need to either create it from scratch or you already have it. After you have this model and you want to calculate it, typically you create finite element model, and this step involves some sub-steps. So you start from geometry, meshing, loads, boundary conditions, all these kind of things. And this is just the beginning, because then you have to consider worst load scenarios using some typical standards. So with worst load scenarios, it becomes a bit more complicated because you have different load directions, different factors you have to account for according to standards. So it can be dynamic factors, safety factors, various positions perhaps. For example, you have different positions of your live load, which is movable load, for example, equipment, or maybe even position of the other part of the structure, like, for example, trolley in terms of heavy lifting industry. And basically all these things that make it a bit more challenging to consider all possible scenarios, so you end up with limited number of load cases to speed up the process. But then it comes to the code compliance, and that brings a lot of challenges, because many software we use in the market, they do not allow directly checking your FEA results with allowable values according to different codes. So you're forced to, for example, export export your model to another code checking software. Then you need to walk through all the steps again. So you need to set it up properly, like you had it in the general FEA package. You check whether your calculated values within the limits, then you import results or make decisions how to implement it in your initial package. Or you do another way around. You say, okay, I'm fine, so I can simply use my old school spreadsheets, because we have it nicely working in a company. And that brings a lot of pain points, I would say, also, because then you need to do a lot of manual work within your general FEA package. But then we have a big question. Okay, what if we have not just one code, but then multiple standards in your more complex projects? For example, I don't know if there is anyone, for example, from oil and gas or offshore industry, but typical question I hear from the people around is that, okay, I would like to check something according to AAC standard, but tubular shapes I need to verify according to API, and some other part according to Eurocode, and another part according to DNV. So how to handle all this efficiently? Do you need different FEA models for different standards? What do you need to do to speed up the process? Do you need repeating this step for every single standard? That's something we're going to close today as well. But then, okay, life is harder, and what is our design is not within the limit. Yeah, so it's also a typical question, because we check design, we see some, I don't know, red spots, utilization factor above what we expect. So we have to figure out what is the root cause of the problem, and then we have to fix it, of course. And then, we either guess what is the allowable weld size, plate thickness to prevent buckling, beam shape to prevent beam buckling, and so on. And we are forced to repeat this analysis over and over again. So after you fix this, finally, you would like to create some basic documentation, report or PowerPoint presentation, whatever. And that's also pretty time-consuming step, I would say. For example, it can be related to your FEM model description or results overview, or overview of the checks you did according to standard. Or you would like to end up with a brief document summary, because it's all time-consuming, like I mentioned. Anyways, these all steps, they lead to a lot of time waste. And this is something that can be also tailored. But then you say, okay, I conducted all these steps, starting from CAD model and ending up with the document. The model is fixed. But then bad luck, client comes or other engineering department says, okay, design is okay, but can we change this couple of plate thicknesses or a couple of loads? And then the question is, do I need to repeat all these steps again? So our discussion today is about how can we tailor the process, how can we tailor the workflow of these engineering solutions. We have the solution that covers all the steps. And what if I tell you that all of these steps, every single step, can be included in a simple, in just a single solution, engineering solution package, and it all can be automated. So this automation we call, of course, SDC Verifier. What you can see now in the screen is our typical workflow. So this software allows you basically to create your model from scratch or use existing models, take into account multiple load cases in pretty easy way. Of course, conduct checks by recognizing your structural members involving multiple standards here, automatically document what you do, and of course, if there is a need, you can fix it. Yeah, and these two arrows, they are added on purpose because if you have any changes, you don't have to repeat this all again and again. But let's talk about it a little later. Of course, typical question is that, okay, is it a specific software for a single industry? No, it's basically involved in multiple industries. So whether this is oil and gas or energy industry, for example, verifying your check platforms and so on according to API, ISO, AIC, Eurocode standards, or whether this is a shipbuilding industry where the plate buckling is pretty common issue there, as well as fatigue. But for heavy lifting, for example, the remaining lifetime is a key point and the main focus point when checking the repetitive loads under dynamic influence. Or civil engineering, yeah, when you have to follow just the standard checks according to, for example, the same Eurocode or EN standard. Machinery and equipment, something that can be covered as well as the aerospace industry. But this is all something general, so let's talk about a bit more in detail. How can we automate these things and what are the possibilities to avoid all these time-consuming steps? First of all, you start from the simulation. You need to create your model, and we have a lot of tools that allow you doing so. Basically, whether it's a simple model or shell model or 3D model, this is something you can use to create it very quickly. But as you know, when it comes to FEA analysis, geometry is just the background for creating the something that is directly taken into account by the analysis. So I'm talking about the mesh. And yeah, because finite element software is not working on top of geometry or your CAD models, but it works with finite elements and the nodes. So basically you prepare geometry to create those finite elements. And then this is pretty common pain points in terms of the nice mesh quality. For instance, okay, you have a simple geometry, or sometimes you have, for example, the cutouts like you have here, or even more complicated transitions. Yeah, small details you have to take into account. But if you noticed on the market with alternative software solutions, this is pretty challenging part to make your mesh quality high quality, basically. We have a nice meshing toolbox that helps you to overcome these steps. Yeah, in 90% cases, that works very well without any hand additions or editors. But if you need that also can be done. So basically, these manholes or these cutouts, they can be easily handled with a nice mesh quality. And even if you need to quickly increase or refine your mesh, it does it very well. For example, like you can see now in the screen. For different parts, it's still, it keeps the mesh flow with a nice element size. But like I mentioned, idea is that if you need to locally, for example, improve one finite element, two finite element, specifically in some area because you'd like to get it that way, that's also possible. So with all these tools like geometry and meshing, you are able to create various models. So it can be 1D models here shown in the bottom right corner, or 2D plate models, or even 3D models you see in the screen. Of course, different complexity requires different amount of time, but be sure that, yeah, with these two steps, you can do it pretty fast. There is a question, okay, can I somehow tailor even this process? Because making something from scratch is nice, but can we use some parametric modeling? This is something we have in our toolbox as well. For example, like you can see for this heavy lifting structure where you can automatically create the model just by filling in dimensions. In addition to that, we have also something a little more general. So this is file to model. So if you have, well, basically having a standard or simple Excel file, including your FEM model information, you can import that and the model will be created for you. But then I would say the logical question would be, okay, do I really need to do all these steps? Maybe I already have some model, maybe it's a CAD model from already mentioned, I don't know, AutoCAD or Tekla or any step file. The good news is that you can use your existing models and 3D files and import them directly, because this solution is compatible with multiple software on the market I started from at the very beginning. Yeah, so whether it's an ANSYS model, it can be directly used by SDC. Whether it's a step file, Tekla, Abacus, you can just import that and then continue working with your FEA model. Creating the FEM model is nice, but then you run into another step, which is the load application. So you need to apply your loads and boundary conditions, and there are some of them that are a bit more challenging than the others. For example, when talking about the wind or buoyancy tank and wave load, these are pretty complex loads, which bring a lot of challenges to FEA users to properly account it for. So this is something that is also automated by SDC Verifier. So when it comes to buoyancy load, you're able to account for a non-uniform water pressure acting on the construction. Same thing about the tank ballast, or for example about the wind load, which is a common pain point among the industries. So there are a lot of standards that prescribe this load non-uniform over the height. Yeah, so it's increasing with height, and basically SDC brings a lot of nice features to apply it quickly. But okay, this first step is pretty clear. So there are multiple ways to do that, to have your basic finite model. But then the question is, how can we take into account all the worst scenarios I was talking about at the very beginning? I think every one of you have seen a typical example from the standard, for example, like this one from EN 13001, when we have to combine multiple different loadings. So you have a lot of load types over here, and these load types are divided by different categories of load cases, and they're all different because they have different partial safety factors, dynamic factors over there, and all this in combination with wind direction that leads to multiple different load cases. We also know that multiple people around the world, they got used to their old school Excel files. Yeah, so that's the way how can you linearly combine your load sets and then use them further. So we decided to keep the same approach also in this software, where you can simply copy and paste it from clipboard directly in the software. Or another alternative is that you can create it from scratch. But then there is the question, okay, we have different standards. We got used to these Excel files, which sometimes are also time consuming, and they lead to kind of this, matrix functionality. Can we somehow automate that? This is something, some nice feature we have in our set as well, which we call predefined load cases. Yeah, but because basically whatever standard is, whether it's EN 13001, Eurocode, whether it's ASCE standard, you have this the same load categories, you have the same partial safety factors, and you would like to always take them into account regardless the model you do. So this is an alternative way how you can automatically create your load cases. How it looks like, even if you have multiple positions, for example, like in the crane model, or this is a different live load, or the wind direction, you can also automate this step. Yeah, so by taking into account different positions, it will create you the same type of the load case, but then duplicated for various positions. Another nice thing in this predefined load combination set is that there is no need to open your standards to check these tables, because we implemented everything for you. For example, you can quickly check what are these typical tables. So you can check yourself, you can see where it's coming from, and yeah, basically you skip this step to open the standard. You can also adjust your dynamic factors. Although you can still use recommended values prescribed by the code, this is something you can adjust according to your needs. So basically, you have quite some options to quickly create all the load cases. And of course, after it's done, you can, the next logical step is, of course, running your analysis. So when it comes to SDC Verifier, this is a SimCenter Nastran-based solver, and it has in its set multiple different types of analysis. So starting from simple linear analysis, normal modes, vibrations, buckling, some dynamic or even heat transfer, and of course nonlinear analysis. So idea is that you use one model to check it for different analysis types. So I think everyone is aware of the Nastran solver. What is it? Because it's been developed many years ago and widely used by NASA. And it has a pretty extensive manual so that you know, okay, what is the logic of the solver itself. But then there is a question, okay, we ended up with this step. The next logical step is that we want to conduct our checks. So of course we can use our hand calculation spreadsheets to do that based on our basic outcomes, but this is definitely not something we would like to go on, because having your finite element model, we should remember that it consists of finite elements and not structural items. So standards work on top of the structural items. So whether it's a beam element, a column, plate field, weld, bolt, rivet, these are all structural items, and we need to give idea to the software to recognize them. Pretty common pain point is that, okay, how can I do that? Because typically in your general FEA package, that is not possible. So if you have a global model and you are interested in, let's say, verifying some local parts, so you need to export that to some FEA model, verify it, get some results, and then update your global model or make appropriate decisions. And this is all time consuming because this importing, exporting thing, that requires a lot of efforts. And in many cases, you would like to keep everything, you would like to keep it consistent because it's easy to get lost. So, of course, this approach is not the most efficient in the world. And instead of this, we suggest all solutions in one software. So basically, one model for everything. You don't have to export anything anymore. And how can we do that? The question is. The answer is that we have pretty powerful recognition toolbox that helps you automatically identify what are your structural items. So whether this is the joint or connection, for connection check according to Eurocode or joint check according to API, ISO, and so on. Beam buckling, so it recognizes all the beams. Of course, weld finder and panel and stiffener finder. So basically, these four tools make it possible to conduct any type of check according to any standard. Just a simple example. So when you're coming back to the same model, you have all these tools in an upper ribbon. All you have to do is to click Find button, and it will be recognized in a second. So just an example, you see, okay, these are the welds in this simple model. Advantage is that you can find out all information very quickly about every single weld. For example, you can set up the weld dimensions, weld types. What's more important, it can be visualized. For example, when you select them all, you can plot weld throat thicknesses, with labels directly on top of your welds. You can quickly visually see, okay, which weld is what. You can also plot weld lengths with your labels. And of course, many more things for this. This is something that is also nice to have for the welds, is the hotspot stress method that is also available in SDC Verifier. But idea is that all the things, they're applicable to all recognition items. So whether it's a beam, panel, or a bolt. It nicely works on top of this simple model, but it also works, of course, on top of the complex model, for example, like the whole ship. So this is a typical example of the recognized welds on top of your ship. Although the mesh is relatively coarse here, as you can see in these pictures, it does not matter what kind of mesh size do you have. Whether it's coarse or fine, it will be recognized in exactly the same way, also including your weld intersections. Idea is that all your finite element results, so the stresses, will be automatically converted in weld direction and then further used, for example, for fatigue checks. And yeah, similar logic is, of course, for checking the weld capacity. You would say, okay, nice, this is all works for plate model, also for beams, by the way, but what about solids? Great news is that solid weld recognition is available as well. For example, when checking this typical example for a solid cylinder model, after the recognition, basically it also highlights all the welds included in this solid model. You can plot them, and all the previous features are, of course, available too. When it comes to complex models, I would say the nicest, the best way to automate this is recognize them all together. Because when you say, okay, I have complex model and I need to recognize everything, basically beams, panels, welds, and so on. For that purpose, we have a nice feature we call recognize all items. So no matter what you have in your model, whether it's a weld, connection, beam, joint, and so on, by clicking this button, you can recognize them all together. Yeah, so it's a matter of your model. It will automatically define what you have and how it should be recognized. After it's done, the most logical step is, of course, conducting your checks according to standards. And this is something that we are proud of, because when checking the standard database in SDC Verifier, that turns out to be pretty extensive. We have multiple different checks in various standards already implemented. So starting from Eurocodes, AAC standard, DNV, DIN, NORSOC, Bureau Veritas, ABS rules, and so on and so on. And what is the idea? If you also, by the way, do not see something on this list, this is something that can be added further. Yeah, because this list never ends. It's continuously growing, and it's all coming from our clients. Something which is very nice to see is that all the checks are completely open. So it doesn't matter what standard you have, whether it's a DNV or, I don't know, ABS standard, you can check full procedure by your own. So you can preview these formulas, and what's more important, you can edit them. Adding the formula sounds pretty good, no? How can you do that? What you need to do, you can convert your existing standard to custom standard. I know that that's not a rare situation when you need to adjust slightly your standard. For example, you created a Eurocode and you would like to replace this factor, let's say, of 1.5 by 1.6 for whatever reason. Yeah, this is your internal company's procedure. So you can adjust the formula. You can set password protection, and you can share it with your colleagues. What's more important, you can store it to the library. And then this standard, this modified standard, can be used further in your all next projects. Alternative situation is that you can write your own checks. For example, like in case of this simple static stress check example. Yeah, because receiving basic stresses, of course, not enough. For example, when following for example, the same FEM standard, you have different safety factors for different directions you would like to account for. And then when you compare your calculated stress to allowable stress, you end up with completely different situations. So people are interested to see, okay, this part is okay, this one is not okay. So for example, the red spots here do not mean that this is something that fails, because when you check it according to rules, turns out to be that this is a tiny spot over there, and the rest of the structure is fine. Yeah, so idea is that you can write your either simple checks, or you can also implement your whole spreadsheet. For example, for years, you've been using your calculation spreadsheets. So it doesn't mean that you have to keep using it in the future, but you can simply implement it and automate this process as well. Yes, this is related to both simple checks working with stresses and also something that works with forces. For example, like a bolt check in this example. So something also nice to know, how can we represent our results? Yeah, so typically we represent our results with plot and the table, whether it's a plate buckling, for example, here, where you see that your couple of plates directly fail, or the extensive table. Something very common among the other checks is that there are multiple different table types. So idea is that every single item you see in the software can be added to the table or removed from the table. So you can make it completely customized. Whether it's allowable values or intermediate parameters used in the algorithm of the code checking solution, everything can be added to the table. Of course, it's also related to the welds and fatigue, which, by the way, is very close to the realistic scenario, as you can see in this typical example. We keep showing it because that was a very nice. This crack over 30 centimeters was found inside of the structure and was overlooked for years. Yeah, so fatigue and fatigue approach is based on the Palgrave-Minor rule, and basically it takes into account multiple different things, including the weld qualities, weld types, load increment history, all the things you can familiarize yourself with in the software. Yeah, and of course the beam buckling, because this is also something common and you'd like to see what are the things. But in addition to the open checks, you would like to know, okay, I don't want to check all these procedures myself, yeah, what I mentioned at the very beginning, but I would like this software tell me what is wrong and what is right. So for that purpose, we have full calculation history available. For example, you conducted a plate buckling check and you would like to see the details. You have full history available. So you see, okay, every single parameter, how the effective radius is calculated, how the section modulus is calculated. What's more important, you see both a formula and the values used in the formula. And with deep step by step, you end up with the final calculation value. And I would say this is a huge advantage for your quality assurance department that ensures that all your steps were conducted appropriately. So idea is that you can export this to a simple Word document, share with your colleagues, share with your QA department, and that's how you ensure your consistent steps. But something I mentioned at the very beginning, this is just one standard. What do we have to do if we have a bit more complex structure and we would like to apply various codes for this? For example, like for this one, let's say we would like to check the upper part, which is made with plate, as well as stiffeners according to DNV rules. But the support for this part, we would like to check according to AIC rules. For example, beam buckling of these rectangular shapes. But then we say, okay, the upper part is made of rectangular shapes, but the intermediate one is made of tubular shapes. So I would like to check them according to API, NORSOK, and ISO standard, as well as the joints that are created by these tubes. Yeah, and last but not least, but the bottom part, I want to use according to Eurocode standard. So all the welds there, including fatigue of the welds, I want to use according to Eurocode. Question is, do you need to do all these things separately, maybe separate models? The answer is simple, no. You can create them all at once. You can use different codes for different parts of your model. It also means you don't have to reanalyze the basic things in your structure. You can still use the same loads or create multiple loads at once and just apply different rules for different parts. Yeah, so what you can see basically in this screen. Many codes, as you know, they also have cross references to the other standards, for example, like ISO standard that suggests using AIC for non-tubular shapes, and vice versa. When using AIC, it suggests using, for example, API standard. So this is already integrated in the software. But when talking about, for example, the same API, NORSOC and ISO, you say, okay, they're pretty comparable. Yeah, so logic is pretty similar. Can I somehow quickly find out what is worse, what is the best, and can I compare results of all these standards? For that purpose, we also have something we call comparison standard. So this is not a typical or standard rule prescribed by the societies, but this is something that you can use to compare results between various codes. For example, when talking about the same API, NORSOC and ISO, you would like to check the worst parameter, which is the overall check. Yeah, so it summarizes, let's say, worst results over all checks included in each standard. And then you would like to compare all the final parameters between each other. So what does it bring to you? It creates another type of the standard with the overall parameter, and that shows you directly comparison between three separate codes. What's more important, it shows you what is worst. For example, if your goal is to check all three standards and then follow the worst outcomes, that's the best way to go. Yeah, so with this tool, you can get a quick overview over the various codes. But then you say, okay, I conducted all these checks, but I ended up with not the best results. So what if the design exceeds the limits or fail to comply with the standards? Do I have to guess all these things and then, jump in back and forth, thinking what is the plate thickness shape? This is something that you can tailor in your process as well. For example, when it comes to beam members and joints, you can simply come up with the list of things you would like to check, and the rest thing is done by the software. So software identifies automatically which shape is better, what result is of this shape, and it compares the results between these different shapes. So idea is that you're not guessing, but you are getting all results at once, and it shows you the optimal solution according to your inputs. Same thing, of course, can be applied to your plate buckling things. For example, your plate fails and you don't know what plate thickness is going to be, or your stiffener fails and you need to come up with alternative shape for the stiffener. This is something that software solves as well. And it's not, of course, limited by the welds, because if the capacity of your weld is not enough to take the force, basically software shows you what are the optimal results depending on the weld type and, of course, the weld size. Yeah, which I would say a huge time saver when it comes to solving the problems. So I would say this is one of the last steps before the creating documentation, because in the end you would like to document this thing somehow. So for that purpose, we have a very extensive reporting tool. So when you go to the reports, you can already notice that there are multiple different predefined reports. So if you don't like to, come up with a new bicycle, there are standard documents you can use directly. For example, something related to your FEM model setup, or results overview, or both together, or maybe creating a short overview in the PowerPoint presentation. That is all possible. So when you go, for example, to the reporting window, this is how it looks like inside. So you have many options here in the top ribbon, and this is some of them. So you can import every single item. You can create your own template, whether this is FEM model information, so COG, materials, properties, loads, boundary conditions, whether these are the outcomes, different table types, different plot types, maybe some diagram for beam members, whether this is something that helps you understand behavior of the structure, or maybe even part of the different documents. Let's say you have two SDC files and you would like to, cross-link them together. So there is an option to use different SDC files within the same report environment. Or even more important, you can attach the separate document to it. For example, you have a typical, I don't know, compliance or guidance rules that you would like to create by default in your report. You can link a typical Word document to your standard template in SDC Verifier, and it will be included in the generated list. So in general, after generating your documentation, it's nicely sorted by different chapters and sections. So you can use bookmarks, for example, in PDF document, if you want to quickly find out or get to a certain section, or using the navigation pane in the Word document. But the idea is that this is exportable to all popular format files. So you did all the steps, and then you're happy. You're going to approach the closure of the project, but then you got last-minute changes, and you need to change your plate thickness, shape, verification parameter, whatever you have. And the question is, do you need to go through all the steps again? The answer is no, because like I mentioned at the very beginning, you have these two arrows here. These are just arrows, but idea of these arrows is that whether you have any changes in the loads or the model, all you need to do is synchronize your file. So basically clicking the button, and the last step will be updated automatically. Yeah, so you synchronize your model by clicking the button, and just think about it. The model is recalculated. The load cases are rechecked automatically. Recognition is also done automatically. You conducted checks according to rules, you optimized them, and you regenerated your document. That sounds good, huh? You don't have to involve any manual work anymore, and this is something that can save you not just days, but perhaps months. Yeah, but then we have something more for you, because we also understand that, well, in general, every single project is unique. Yeah, that's a default rule. But sometimes we have some typical tasks. For example, we have jack structure, or we have typical barge or vessel or crane structure, or maybe small detail that is different by the very small thing, so which does not really make a significant influence on your workflow. So there is a way to automate these things. We have an open API console, and yeah, that helps you to predefine these steps. For instance, you conducted a project already, so you open existing project file, yeah, you use it as a template. It automatically removes all load cases and adjusts this according to your imported load combinations from Excel, or for example, this step can be replaced by the predefined load cases, which I was talking about at the very beginning. You create one load group because you would like to see all results in one picture or in one table. So at this moment, you don't care about the very, very details. It conducts recognition, in this case of Welds, conducts fatigue check according to Eurocode, generate full report, save project, close it, and for example, send to another computer. Yeah, again, this is a simple example, but of course it can be extended to your needs. So if you need to replace welds by the plate buckling, or even add it here to have bolts together, that is possible. The only thing you have to keep in mind that this process automation, I think it's perfectly works for some typical things, because if you have two different projects, the ongoing one and the previous one, yeah, that will be a bit more challenging. But if you have, let's say, 80% of similarity, this is well works for them. And I think the biggest motivation for us to develop these things to help around the world is, of course, the feedbacks from our clients. We receive them very often, and this is something that drives us to create a nice documentation, to make it even more better. So that's why we constantly organize and attend different events. We conduct online and offline trainings. We have a lot of tutorials, articles, YouTube channel that grows a lot. And yeah, this is something that can be used to quickly familiarize yourself with all the process. Besides that, because this is a nice solution all at once, but besides that, we recently started developing the web-based tool that helps you to manage your structural assets, yeah, and organize the maintenance control. Because the question is, okay, we have so many different result types, we generated report, but when it comes, for example, to the remaining lifetime of the structure, this is something that you would like to be sure about. Yeah, because the remaining lifetime of the structure that creates localized fatigue damage that can grow in time, and regular inspections and proper maintenance control is must-have for this part. So SAM platform, this is something that helps you to manage these things. What is the idea of this SAM platform is that whether you're a big company or a relatively small terminal, basically you create different assets. For example, you have one part for STS cranes, then you have mobile cranes, and then some other part of the structure, or you can divide it by the different categories of your structure. So it's up to you, but idea is that you can group them together, and each group includes local details about every asset type. So for example, when talking about the first asset, STS crane, what you see, you store the main information about your asset. So the location, where it's located, maybe some pictures, overall risk level, and of course the damage type. Because the typical question is, what is the overall damage time for my structure? Is it still suitable for the further use? So the answer for this question is pretty complex, because the overall damage type is defined by the multiple damages in different assets. But let's talk about it further. First of all, the details of every single asset includes multiple information, like reports, for example. So you can upload automatically reports from SDC Verifier. So you got some report, you can link it over there, or you can link the inspection report conducted by your inspector, or you can link, for example, FEA models, drawings, grow your own database. And idea is that you can set up the roles within your company. For example, inspector has access to one part, engineer to another one, and the owner to all parts simultaneously, which is good in terms of the sharing information. But when talking about the details, let's focus on the main asset. So typically, when, for example, focusing on STS crane, but again, it's not limited, it can be any type of structure, it includes multiple large areas. Yeah, for example, if any one of you have seen once in your life the hinged connection in STS crane, you can already imagine how large is that. Yeah, but how many different connections you have? Pretty a lot. And every single connection, that's also we call asset, by the way, has a different health status. So one can have critical health status, another one good, third one fair, and so on. And summary of these statuses define the overall health status of your structure. So when talking about the local connections, for example, hinge point, basically the hinge point is also pretty large. So you get these things also grouped. Yeah, so whether it's a hinge point or maybe connection with the forestay or some other spot, and basically every single one has its own definition of the health status. But when you take a closer view, for example, about connection with the forestay, it's a large zone, and this zone includes multiple more local areas, which are not okay according to standard. These areas can be classified by the different health statuses as well. Yeah, especially, for example, when it comes to the corrosion, whether it's a local corrosion or global, permanent damage, deformation, maybe a damage of the weld or existing crack weld. So basically, that all defines the overall status of this specific connection. But even this zone, a local one, can be classified as well. Because when you check, for example, one point, so inspection point 1, yeah, you can see a lot of details for that point. First of all, what is the plate thickness? Yeah, was there a severe corrosion or not? Is there a crack already initiated? What is the crack length? Yeah, what is the damage type in general? And these things identify the overall risk level. What's more important, you directly include comparison with the real visual inspection. And these things help you to create your maintenance plan. And what's more important, it reminds you when do you need to inspect one part or the other part, because having one structure, yeah, that is pretty challenging. But having dozens or even hundreds of different structures, that becomes quite complex. So yeah, with these tools, basically, I think you can make life much easier than it used to be and organize the continuous workflow by tailoring this according to your needs. This is briefly it. We had a limited time today, just 1 hour. We can talk much longer about it, but unfortunately 1 hour makes it a bit more complicated. So I'll be happy to answer your questions right now if you have any. And yeah, let's talk about your cases. All right, I'm just checking out the chat and I see already some questions. What is the precondition for Welds? This is a question from Human Abdulli. What is the precondition for Welds to be recognized in the origin FEA software, say ANSYS? Is it based on bonded contact definition? Whoa, there are a lot of preconditions, Oman. So whether you have a bonded contact, whether you have a common mesh shared, basically there are that still can be recognized by the software. So it doesn't matter whether you have a contact or you have the shared topology, it will be still defined in the correct way. There are quite some rules for that. So these are custom, these are recommended rules by SDC Verifier, but they can be adjusted according to your needs as well. For example, if you have a plate intersection, so for example, different angles between the various plates, like over here, so intersections between the plates. So if it's a plate model, let's say, intersections between the plates positioned at different angles will be recognized as the well. And by the way, what's also more important for fatigue, it will also define which plate is welded and which plate is a base plate. As you know, for fatigue, when defining the notch classes, this is essential because this plate, let's say, the weld related to this plate is having lower characteristic fatigue strength than the base plate, which is sometimes called non-welded part. So yeah, both are available. Not sure if I answered your question. If no, please unmute yourself and ask more specifically. Meanwhile, I will go to the next one. Is it possible to perform Section 8, Part 5 FEA analysis for SDC software? Yes. So when it comes to ASME standard, we have Section 8. We have also ASME B31.8. We have ASME BTH1, which is also available in SDC Verifier. Then fill out the form here too. Okay, that's not the question. What is the next one? Standards prescribe many different characteristics based on the dimensions of structural items. Should I configure them manually? By the way, that's a nice question because all these dimensional based characteristics, let me scroll back a bit. Where was it? For example, here. Yeah. So again, what I'm going to say is applicable to any kind of structural item. But idea that with this recognition, SDC also recognizes the basic dimensions of your members. For example, if it's a plate fill, it determines what is the width, what is the length, what is the plate thickness to calculate the slenderness, and these things are automatically included in the checks. You don't have to define this manually. Of course, there is an option. For For example, if you don't like a certain plate thickness in your plate field or this local plate, you can change it without changing your FEA model. So change it for check, yeah, with a certain thickness factor, let's say. So you say, okay, this plate is corroded and I want to reduce this plate thickness. This can be done as well. But the basic dimensional characteristics are accounted for automatically by the software. Whether it's a beam where you have to define the beam buckling length in different directions, joint, weld, and so on. Okay, you mentioned that the software handles complex models to conduct various checks. However, complex models sometimes require significant computational time, and it can be easier or faster to check just part of the model. Does SDC allow this option? That's also a good question. Let me find maybe another example here. Where can I find it quickly? Well, let's talk about this one, or maybe even the short answer, yes. For example, this one. If you say that, okay, I have a large model and the upper part, for example, or the bottom part is conducted with multiple finite elements, and you are worrying about the calculation time because this is something that is inevitable regardless of the software. What you can do, this software deals with selections. So idea is that you can have global model including all the finite elements, but you can, for example, say, I want to analyze just this part without creating a copy of your model, or without going deeper over there. You can just select this part and tell to the software that I want to analyze only this part, and then all the loads and the checks will be applied only to this part. So I hope that answered your question. Another one, I also noticed a tab for hotspot stresses in your short video about the welds. Are the stresses directly accounted for in the standards? Yes, they are accounted for in the standards as well. As you know, many standards, they're based on the nominal stress method calculation, for example, like fatigue, but more advanced standards like Eurocode or IAW, they prescribe hotspot stresses. So hotspot stresses is an optional case, so you have a checkbox whether you want to continue using the nominal stress method or the hotspot stress method. So this is all accounted for. Under AS 3990 code, is it possible to do both ASD and LRFD checks? Yes, of course. So every beam member check standard, for example, whether this is AAC standard or AS 3990, both methods are allowed. This is up to you. It's more a matter of the load cases created, for example, because you know that for ASD and LRFD checks, you are forced to use different safety factors. Yeah, and the partial safety factors. But short answer, yes. Check the same model under, sure you did, okay, thanks, good. Check the same model under different standard is cool. Yes, I think this is something we're very proud of because this is something this is pretty common thing. If you have a large model and you need to comply with AAC standard for non-tubular shapes, and for example, for this one, for tubular shapes, that's a huge time saver. Moreover, you don't have to create even separate ones because there is a cross-link in many standards, for example, over here. So you can, in one standard, basically covers multiple cross-reference standards. So that's also some time saver. Can you perform time history analysis with SDC software? Yes, of course. By the way, that's a very nice question because it also depends what you mean with time history analysis. Is it, for example, a rainflow counting method or a simple Palgrave-Minor rule method? But short answer is yes, both are available. So you can use a standard Palgrave-Minor rule, for example, involving a hotspot stresses and determining the remaining lifetime, or you can apply the rainflow counting method directly in the checks. Seismic. Yes, it's also possible. This is part of the general analysis type in the software. But also, I would say it's not specifically related to the code you apply. This is more a general analysis, but yes, this is possible. It's over there. Okay, quite some questions, I would say. But I just scroll down and I see that I ended up with all of them or are close. So if you have more, don't hesitate to write, because it's already 10:02. Don't want to keep you for too long over here. All right, colleagues, then it was a pleasure to give you this presentation today. There will be another session, by the way, today later at 4 p.m. So if you wanted to invite some of your colleagues, but they didn't have chance to join here in the morning, that's the chance to join again and once again to talk about these things. By the way, also asking some other questions. So at this point, how easy is it to learn your software? It's very intuitive software. Everything is directly related from the same ribbon. But again, I think the best answer to your question is our educational environment, because whatever check you use, whatever type of check and so on, typically we prepare a separate tutorial for that, where every single step is explained. We have also a YouTube channel where you can find out more for the various topics. We also have a very extensive help section. It's not a standard help section, like most of the programs suggest. This is very extensive. Typically, every single button, action, feature is explained in detail over there. So if you're passionate on, learning the software, I don't think it will take you a lot of time. But if you're struggling and if you have a time pressure projects, for example, then there is an alternative. We provide dedicated trainings specifically for your projects and for your company. So idea is that you just choose the various topics you're interested in. You can even choose your model, part of your model, come up with agenda, and we will guide you through every single step. Yep. And by the way, if you say that you have an Abacus background, I would say it doesn't matter, because these common pain points I was talking about at the very beginning, they are indeed common. I don't think you disagree on this. So yeah, that's the way to familiarize yourself very quickly with the software. All right, guys, it's already 10:05. Again, if you have more questions, I can wait for another 10 seconds because I see they're all the time coming. If no, then I would say thank you for attending this session, and I hope to see you at the second part, or your colleagues at the second part of this webinar. Thanks again, and see you soon.